Hi everyone. So let's continue with the building the polynomial regression algorithm. First step is my extract data. For the extracting data, first I have to import pandas. Import pandas as PD, and I will take data where I will read the data frame PD dot read underscore CSV. In this, I will pass the file location. I will print the first 5 rows of the data with dot head method. Before that, make sure that you have to select the kernel python exe double slash double slash. Make sure you have to give the double slash or this one or this one. You can use anything. If I run this, it is connecting to the kernel. Now it is executing. So I found this is the data frame. Okay, you can use any data frame you have. So for now I am using this only, and now I will check whether it contains null values or not. Data dot is null dot sum. There are no null values. Now I will take the information about each column. Data dot info. Right. So I found integer type is for both level and salary column. Position is object. Data dot describe. It will give me the description of the column, which is not an object. And it's time for changing the object to integer, which comes under feature extraction from sklearn dot reprocessing import label encoder. We'll take it for in the variable label encoder. I will change it for data dot ilog index location for all rows only for the first column equals to le dot fit transform will pass that same column, so it will update the same column. And instead of this one, you can also pass the data column name as position within the double quotes. You can also write like that, no issues. Now I will check data dot head. If I run this, it the position is changed to integers format. It is mapped. The next step, I will take x equals to data dot ilog all the rows starting from everything, comma, except last column. Y is equals to data dot ilog include all the rows, only the last column. We'll change it to values dot values. Now let's display the result. Print x. Okay, x is not displaying. I have to keep it small. Now okay, it is in the numpy array. Print 12. Done. Now I have to model building. I have to start the model building. For the model building, I have to tell that this is the polynomial equation which have the degree of 4. Before that, from sklearn pre-processing import standard scalar sc equals to standard scalar x equals to sc dot fit transform of x. Now I will tell from scalar dot preprocessing import polynomial feature pr underscore model, which is nothing but the polynomial regression model, equals to polynomial feature with degree of 4. Now x poly is equals to pr model dot fit transform for x. Done. Now I will apply this for the linear model from sklearn dot linear model import linear regression. Now LR is equals to linear regression LR underscore model. Now LR model dot fit x poly comma y. Done. Now evaluation matrix. I think we can also add one more thing, linear regression x poly and y poly. And for this one also we can copy this line, add this here. PR model is this one and the linear model is also this one. Let's say this, make it as PR 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 underscore PR underscore model equals to linear regression PR model dot fit x poly comma y. So here I am having the polynomial equation for polynomial degree of 4, and here I am having the linear regression for degree 1, means it is a normal line equation. Okay, 1 and 2. Evaluation matrix for polynomial from scalar dot matrix import R2 score, mean absolute error, squared error. For normal mathematical collection, import numpy as np r print testing score and print training score. Before that, test underscore sc equals to model dot score pr underscore polynomial regression model score x poly comma y. Train score equals to pr underscore model dot score. So okay, so there is no training and testing score. I will take this as LR linear model score, linear model score, and polynomial score x comma y. Polynomial score is poly score, and a linear model score is linear SC. Wherein this, so polynomial is trained for 100% and linear score is 0.78. Now I will have the prediction y pred equals to, for the polynomial equation dot predict x underscore poly print y pred. This is the prediction value for polynomial equation. Now it's time for mean absolute error, MEAE, equals to mean absolute error between y comma y pred. MSE is equals to mean squared error y comma y pred. RMSE is equals to NP dot SQRT for MSE. Now I will print those three, and also R2 score. R2S is equals to R2 score for y test and y pred. I will pass y only. I'm getting confused because of I am habituated with the previous course. MEA is passed. MEAE, mean absolute error. Print mean squared error MSE. Print RMSE. RMSE. Print R2 score comma R2S. Okay, it should be the comma here. Parenthesis. This is the what I got. Now let's start with the visualizing the results for polynomial and linear as well. Matpro import sensitive code import matplotlib dot pyplot as plt dot plot for x and y. Plt dot show. Before that, you have to give plt dot title as linear regression. Okay, plt dot x label as level. Plt dot y label as salary. Plt dot scatter x comma, or we can use dot also, lr model dot predict x. If I run this is what I am getting. If I commenting to visualize perfectly, it is coming like this because I'm having the two features here. If I use the entire column, entire rows only for the second column, and in the same way for this also. If I run this, if you see here, this is my the uh, prediction, and this is my the raw. This is how it is coming. If I use this one like this, if you see, I have the multiple features. If I use comma 1, then like this. To avoid this one, you can do one thing here. In the feature extraction, you can consider only one and run all cells below this. I am getting like this because I am holding the only one feature, so no need of this one. If I run again, this is my what my linear regression looks like. For the in the same way for the polynomial result, I will just simply replace PR and here with x poly. Okay, this is what I am getting. So this is my polynomial and predicted. Why am I like getting like this? Because I have trained the entire model and I am predicting the entire data set. That's why it is looks like the same output. This is how you can. So this is my polynomial result. And this is my linear model result. And LR model and PIR model is nothing but polynomial and linear model. This is how you can implement the polynomial regression. And once again, I will do the recap. So polynomial regression is nothing but the polynomial equation where the feature to the power of nth power, and this is the example how it looks like. Y equals to mx to the power of power 1, 2, 3, 4 respectively, and first I have to extract the data, then I have to check whether it contains null values or not. After that, getting the information about each column and get the description. After getting the description, do the feature extraction, and in the feature extraction, first step we have to map each value of the position to the integer value and replace them using label encoder, which is inside the pre-processing module. After that, in the x and y values, take the second column, which is the level 1 and salary in x and y respectively, and check whether the result has been updated or not in the x and y. In the model building, you have to use the standard scalar for the dimension, and in the polynomial you have to apply the polynomial equation for those for the features x. For that, I have to import the polynomial feature and apply the degree 4 to the variable pr, and pr dot fit this model to update the feature, and I am storing the value in the x poly. After that, I have taken the linear regression to train the model which has the polynomial features. Okay, till now this is a polynomial feature. Now I am taking the linear regression also to compare both. Now I am evaluating the model for the polynomial and linear. So this is my equation which tells this is my polynomial score. Equation score is around 90%, and same thing for the linear model, it is about 70%. Now I am predicting the results for the polynomial equation, and I'm finding the mean absolute error and absolute squared error, RMC value, and R2 score for the Vibred, which is the polynomial equation, which is related to polynomial equation. And this matrix is for the polynomial equation. After that, I am visualizing and comparing the results for linear regression and polynomial equation. This is my polynomial. Polynomial regression. In the here, if you see, I'm taking the linear model LR and predicting for the value x, and this is the entire best fit line for the linear regression. And if I take polynomial equation, it is exactly with the same trained set. That is why in the polynomial I am getting around 1, because it is exactly matching. If you see here 60%, that's why it is something okay. It is nearby best fit. This is how the polynomial equation is built. That's it. If you have any doubts or need any expression, let me know. Thank you.